This is Brandon Allen. This is my video submission for assignment 1 of Math 1510. The question I've chosen is question 6, is the proof by induction that the sum of integers from 1 to some capital N equals capital N times capital N plus 1 times 2 times capital N plus 1 all over 6, where capital N is a part of the positive integers set, the set of positive, where n is a part of the set of positive integers. So the first step is to test capital N equals 1. That's our base case. So on the left-hand side, we have one term, because we're starting at 1 and ending at 1. So it's just that 1 squared. And that equals 1 substituted into this expression up here. So substituting in 1 each time, we get 1 plus 1, 2. 2 times 1 plus 1, 3, which is 6 over 6, therefore equal to 1. So that's satisfied. The next step is to assume capital N equals k satisfies, where k is also a part of the positive integers set. So we have, starting from our first term being 1 squared, and then the second term 2 squared, all the way to our case term being k squared. We're adding them all up, and we're assuming that that equals this expression here with this instance of a positive integer satisfying. So that's just that with k substituted in instead of capital N. The next step is to prove that capital N equals k plus 1 satisfies. So again, we have a sum, but it has one extra term, which is our k plus 1th term. So it's just one term longer, and includes the previous sum. And then we substitute k plus 1n for n. So n becomes k plus 1, n plus 1 becomes k plus 2, and 2n plus 1 becomes 2k plus 3, all over 6. So our left-hand side equals this. And the reason that is the case is that we're using our assume to put this expression in here. So that expression comes here, we're left with that. Now what we can do is pull k plus 1 out of here and here. We can put this k into these brackets, giving us 2k squared plus k. And then to give the same denominator, times this k plus 1 left over by 6. So we have it all over the same denominator, and we have a k plus 1 factor out front and a quadratic left over. We can factor this quadratic into this piece here. If we bring 2 outside of that bracket, we end up with this, and then those 2's will cancel. So then we're left with k plus 1 times k plus 2 times 2k plus 3 all over 6, which is our right-hand side. So it satisfies. So in conclusion, the sum of integers from 1 to capital N, which is some number in the set of integers, is equal to capital N times capital N plus 1 times 2 times capital N plus 1 all divided by 6 by mathematical induction, in the case that n is a part of the set of positive integers. All good?